this question actually gives me the opportunity to introduce another concept, well, slightly more developed concept of the row echelon form. And you have to be aware of that concept. That's why I'll use this opportunity and I'll show you this concept. Look, this method, this Gaussian elimination method, remember the method which took this matrix down to this one via elementary row operations, you can actually do this method on this matrix a little bit further. I mean, you can of course take this matrix and already do your back substitution, but sometimes it may be convenient to take this method extra few steps forward or further. And for instance, you can cancel this 7 by multiplying the last row by 1 on 7. So if I take this method a little bit further, like this, if I make another set of elementary row operations like this, if I take the third row and I send this row into 1, 7 of the third row, the result will be, the first two rows will be the same, but the last one will be just 1 here and -1 here. That's all there is to it. So I will open it quickly. That's the one. First two rows are identical. The last one becomes like this. Now, what you can see, what happens actually, all pivots now are, look at this, all pivots are identities now, ones. In all pivotal positions now we have ones. You can always achieve that by just canceling whatever sitting in the pivotal position. Because this whatever sitting in the pivotal position, it is non-zero, you can always cancel by that. Otherwise, it's not a pivotal position. Now, what you can do extra, you can use this pivotal ones to cancel the elements which above the pivotal positions, like this two and like this one. For instance, if I want to cancel these two elements, the elementary row operation which I have to do is these two. I have to take the second row and subtract the last row and put it back in the second row, and I have to take the first row and add up a third row and put it back into the first row. By doing this, these zeros will not affect any of the coefficients in this part of the matrix, but these two will be gone. And that's the purpose of this step, canceling these elements above the pivotal one, and because we have all zeros before the pivot, anything else will stay the same. Well, the right-hand side will also change a little bit. If you do these two operations, I don't want to pay too much attention to the arithmetic. I'll tell you why in a second. So I will open it quickly. That would be the result. In principle, that you see this part of the matrix stayed the same. We got two extra zeros here, and we got something happened to the right-hand side. Some arithmetic happened to the right-hand side. Now, the last step which you can do now, you can use this pivot. To cancel this remaining one over the pivot, and you will do that by, do I have this one? Yes. You will do that by taking the first row and subtracting the second one. Again, this operation will not ruin the row echelon structure of your matrix because of the lots of zeros here, but it will give you even more zeros. Well, to some extent, I hope you already understand that the more zeros you have in your matrix, the better the system will be, which you have to back substitute. So the more zeros you have, the better you go. That's why some people like to make as much zeros as possible. I mean, some of you will, like for instance me, I don't like these extra steps. My personal preference. When I just come down to this, when I already see row echelon form, I go back substitution right away. But some people prefer to make extra zeros, keeping the row echelon form. All of this is still row echelon form. You see, here's my pivots. And the same set of pivots, the same set of pivots here, right? So all of this still row echelon form. By doing these extra steps, I'm not ruining the row echelon form. Each of these matrices can be taken, and for each of those you can do back substitution. But of course, doing back substitution for this one, it's much easier thing because you got more zeros here. In fact, if you do back substitution here, you will come right down here, right down to this solution. So in fact, these extra steps is just a replacement for my back substitution here. You should think about that a little bit. Now, the matrix of this particular shape, so when the matrix in the row echelon form, and you have two extra conditions. You have two extra conditions that all pivots are ones, and you always have zeros above pivots. With these two extra conditions, the row echelon form actually called reduced row echelon form. That was the purpose of this extra thing, which I was saying, to introduce this extra concept for you of the reduced row echelon form.